So let's continue on with our exploration of functions. Here's some common functions that you're going to see in Math 30-1. The first one is called a radical function. Now you did a whole unit on radicals, but we didn't really graph it that much. In Math 30-1, we're going to be graphing it a whole heck of a lot more. Here's our function. Has to have a radical in it. Its general form is going to look like this. Yeah, this one isn't identical to that one. What happens with this exact one, what you're going to get is it's going to start from 0, 0, the origin, and curve out that way. Don't worry about it. I'm going to show you how to go through stuff like this coming up. It's really, really wild. Okay, let's look at the next one. The next one is something called a cubic function. That's right. These are functions with the degree of 3. That's why you'll see it. General form here. There's our function degree 3. And you know what's really cool? That degree actually indicates the maximum number of cuts of the x-axis. We're going to get into that, exploring that huge. But this is a typical function that you're going to see right here. It's going to cut the axis. It's going to give you some really nice curves. Really sweet. Here's one I want to look at. This is brand new. This is actually a semicircle. I'll prove that to you right away. Cool thing about this is look for two features. Number one, look for a square root under the radical. That'll tell you right away it's a semicircle. But if it's just a square root on its own, look at this. This just means x, and guess what? That power is 1. It's a line. So there's got to be more to it than what you see. And as a matter of fact, look at this. I'm going to erase this so you can see it. Look at this. It's got a k value in there. Ooh, isn't this interesting? Well, the cool thing about this semicircle is this. It's going to have a center, and it's going to be the origin. So in other words, it's going to be right smack right there on our beautiful x, y axis. Now, the other cool thing about it is it's going to have a radius of whatever that k value is square rooted. So if that k value was something like 16, all you got to do is square root it. This guy would be a radius of 4. So you would go from the center here, you'd go 1, 2, 3, 4. From the center here, 1, 2, 3, 4. From the center here, 1, 2, 3, 4. And you would draw yourself, look at this. You would draw yourself a nice little radius and a nice little semicircle. Oh, isn't that pretty? Look at that. But I know what you're saying. Sir, I don't like the way this looks here. I don't believe you. So guess what I'm going to do? Watch this, baby. Okay, I'm going to give you 2 examples. And I'm going to go with these examples with my calculator. You probably saying, you jest, sir. Yes. Well, actually, no, I don't. Let's go throw that into our calculator. Watch what happens. Let's predict it first. So it looks like a semicircle to me. It's got a 25 in it. If I square root this, I should have a radius of 5. So I'll have a dot here, a dot here, a dot here. My center is going to be here. And look, I should get a graph that looks like that. Well, let's prove that. Let's bring up the calculator. Boom. Let's go to our y equals. I'm going to put second square root of 25 minus x squared, and I'm going to graph it and check it out. I get exactly that. Now, you're probably saying, oh, that doesn't look like a semicircle. It looks flattened. I don't like it. Well, one of the reasons why is remember that this isn't a perfect square. This whole thing is not a perfect square. So what happens here is this. It's kind of like your TV set, which makes things kind of short and fat. So if you want it to look real nice, go to zoom and go to zoom square, which is right here. If you go zoom square, watch what happens. That would be number 5. I'm going to hit 5. Look, now you get a perfect semicircle. Now, here's the flaw with your wonderful TI-84 calculators. It doesn't go down all the way down to the bottom. It doesn't go down all the way down to the bottom. Why? I have no idea. I've been fighting with this for years and years and years. So if you know why, email me and let me know why this doesn't work this way. All I can say is this is not an HT calculator, so it's just a mess. So let's go back now to our wonderful thing that we had here earlier, okay? So let's go back. Oh, come on thing. There we go to this. What happens if I put a negative in front of this? You know this from Math 20-1. Math 20-1 means flip it. This means a flip. But now you're not Math 20-1s. You're 30-1s now, which will actually have a specific name for this. We're going to actually call this a reflection. And you're going to reflect this over an axis. So this is going to be reflected over, can you guess? Which axis? This guy is going to flip. How's he going to flip? Well, surprisingly, he's going to probably be down here. So what axis did he flip over? I'll give you a hint. Oh, so this is going to be over the x-axis. Let's try this. Let's put the negative in front of this thing, and let's see what happens. So I'm going to bring up my calculator right here. Boom. Okay, let's clean this up because I don't like all these crazy dots everywhere and lines and everything else. Here we go. Get the y equals 2 again. We'll go down to y2. We're going to put a negative in front of it, and we'll type in exactly the same equation again. There's 25 minus x squared. Ready? Oh, this is so pretty. Graph it. You've got a circle. Isn't that neat? It's a circle, and if these guys actually connected properly, this little gap here and this little gap here would be perfect, and all I can think of is put a couple of dots out here and a big smile, and hey, I just learned you something.